All right, so this is the Tower of Hanoi problem. This is from the Maths is Fun website. And you can see the version that I've got up here has 3 discs. That's the simpler one that we're going to start with. And the idea with this puzzle is to move this tower of discs from the far left over to the far right, so it looks exactly the same. But the 2 important things when we're doing this puzzle is you can only move 1 disc at a time, and you can't put discs on top of smaller discs. So for example, if I pick this little disc up, I can't put this disc on the top because it's larger. Now you can see that on this website too, it has the minimum number of moves that are required, so you can really encourage students to try and get their algorithm to be as efficient as possible to try and get to this minimum number of moves. Or you might even like to do this on paper and not tell students the minimum number of moves and get them to try and identify when they think they've got there. So I'll just show you really quickly with this 3-disc puzzle the solution. So moving the little disc over to the right gives us room to put this middle disc here. Now I can put this disc on top because it's smaller, and now I'm able to move the base over. Now you can't pick this whole bunch up at once, so I'll have to move the little disc off the middle disc and that disc there. So you can see that this is the minimum number of moves, but of course, yeah, students may take a lot more moves to do that. Now in terms of investigating the algorithms and iterative nature of this problem, what you might like to encourage students to do is try, 2 or 3 discs first and try and identify the algorithm that works, and then whether or not they can increase the number of discs and understand that that component that you've just done would comprise part of that algorithm again. So you can see here with 4 discs, it's now 15 moves, and every time you increase the number of discs, the number of minimum moves increases accordingly. So when you get up to 8 discs, it's a huge number of minimum moves. So it's a really great activity because it's very accessible for everyone, and it's really just that idea of students perhaps either working on their own or working in a team to try and identify the most efficient algorithmic process they can have to solve this classic mathematical puzzle.